In this tutorial, I'll show you how in just a few minutes you can have a fully functional customer support chat using AI Gateway from Orq.ai. So let's jump straight into the docs. In this diagram, you can see exactly what we'll build. So first, the user query, when your customer will ask the chat a question that will go through AI Gateway. First, we will build a cache, so your repeating questions will get stored. We also have contact tracing, which will help you to understand who exactly is sending requests to the LLM. And then we have thread tracking. This is useful, especially for very complex conversations where you might need to see if there is a drift off topic. You can see here that we will also add a knowledge base, which is essential if you want to add your own documents. So we'll enrich your query with knowledge about your business, and then we will select two models, a primary model. Here we will go with OpenAI GPT-4o, and then in case there's rate limits or any power outage, we will set up a secondary fallback model as well. Finally, we'll generate in real time a customer response. Step 1 is the Node.js project setup. As my package manager, I'm choosing npm and I'm initializing the project. Next, we need to install the Orq SDK and OpenAI SDK, since this will be our primary model. TypeScript dependencies, and finally, the .env file where we will put our API keys. Next, we need to log into Orq.ai platform in order to set up a project and get the API keys. So step number 1, you click here on Add Project, and let's name it Customer Support and save it. Then I will go to my profile, workspace settings, and from API keys, I will add a new API keys. So I will name it Customer Support. And here I can select the project, Customer Support, and assign the API key to the project. So in our Node.js project, I would like to create a .env file with your actual API keys that you paste in here. So let's see what we have and open a preview here. So here inside the env, just paste your API keys securely. Remember that it's a good practice to actually add your .env file into git ignore. And now we're ready to create a customer support TypeScript file. Inside, we can paste in this code with hello world. You can see a reference in the docs. Once we run it, you can see that we'll get a simple hello world message back. So far so good, but this is not yet an interactive application that we want to build. So step 2, let's add streaming data in real time. The main changes that I did here to the code is that I've connected an OpenAI SDK and we've enabled chunking. So essentially what's happening right now is as we execute the code, you'll see that the streaming is started and your question, which in this case is what are chunks in AI, will get parsed in real time. And step 3, we're adding retries and fallbacks. What changed in this code is that I have 3 retries in case of a failed API call, only on the following error codes. And fallbacks, I have my primary model and my secondary fallback model in case I hit a rate limit. If your customer support application handles a lot of similar customer questions, we might need to build caching. So you can see here that I've built and added exact match type of caching, meaning that the question needs to match word per word. In the code, you can also see that I've added a question, explain Orq.ai retries and fallbacks. The first time I'm running this code, it will be actually cache miss. And we can see that by going to Orq.ai dashboard. In the dashboard, navigate to traces and to the most recent trace. You'll see cache miss. This is to be expected as we've just, for the first time, hit the API request. So I will rerun the code again to simulate customer asking the same question again. Now you can see that we've got cache hit, and in the inputs we have our question, explain Orq.ai retries and fallbacks. Once we created a knowledge base, we need to add some files to it. In the GitHub repository, you will find the sample document that I put under the documents folder. You can run this code to add this document to your knowledge base, and a correct response would look like this. Remember to save this file ID into your .env file. We're not yet quite ready, and perhaps this is the most confusing part. So you've created a knowledge base, you've added a file, but we need to connect the two. And this is where connecting the files with the knowledge base as a data source comes in. Once you get a response that looks like this, remember your knowledge ID needs to land in your .env file. Once you completed those steps, here is a ready code for you to execute to test how differently your customer support chat will respond, knowing more about your company. Contact tracking comes in very handy if you have multiple people sending requests to your customer support chat and you need to control the budget. Here I created a user called John Smith and added his email john@company. I'm running this code to simulate John actually asking something to our customer support chat. Inside Orq, you go to Contact Analytics and I can see John Smith, that is an external person who sent 22 requests at cost of 2 cents. From here, I can click on John and actually set a budget. So monthly, he doesn't spend more than $10. If you want to group multiple traces, thread tracking is an excellent solution. Here you can see that for a unique ticket ID, which is a customer support ticket, we've also set a ticket thread. So all of the customer requests that come under the same ticket will be stored under one thread. After executing this code, you can go to Traces, Threads, and see Customer Support Ticket with the number, and you'll see all of the messages stored in one thread. The final piece that we will add is dynamic inputs. So we want to ask more than one question. In order to do so, copy this code and execute it. Now you can see we are actually prompted for the input. Let's ask, what are traces? But then immediately I get a response. And let's do a follow-up question. What are chunks in AI? And that's it. We've created a fully functional customer support chat with a knowledge base, caching, handling dynamic user inputs.